assume this or don't assume this. So people can understand what the effect of the assumption has to the model. Whereas when you're playing a game like rental cars in Florida, we're not exposing that, we're not telling people about that, and they're not even questioning what that is. They've put themselves into their mind that they are, a manager of this rental car business, they're selling cars, and they're using their own mental model to kind of play this game. Okay, so pros. Deeper exploration. Many times when people use these scenario analysis tools, they get a lot deeper into the concept. Oftentimes there's way less perceived bias. So one of the big things, you'll see when we talk about these management flight simulators is oftentimes students will come back and say, the game is rigged against me, it's biased. In this case, you're making your assumptions pretty straightforward when you're building tools like this. They're a lot more transparent, they're power user oriented because you're running lots and lots of scenarios. It's kind of hard to teach people how these things work. It requires a mental transformation for people to understand that they're using and interacting with a model. In that pricing game, you don't know you're interacting with a model, you're just playing a game. The word model never comes up. But in Healthbound, I can't explain it to you unless I say the word model. It gives them a systemic understanding. Cons, they're dry and boring. You can't spice them up. At least I haven't been able to spice them up. They require a much better understanding of the context by the user. You've got to brief here. I can't just dump Healthbound in your hands and expect you to play with it for 30 minutes and understand how to solve healthcare in the United States. You've got to brief, you've got to debrief, super important. And also the models required of these things, because there's lots of exploration and you're exploring the full state space. They've got to be robust, they've got to be tested, and oftentimes because you're dealing with managers and high-level people, they got to have a lot of detail complexity. So I don't know, have you shown them that slide yet where you have the continuum from detail to dynamic complexity? These models live almost always all the way over on the detailed complexity side of that number line. People want to be able to see themselves within the model. They want to, so I did a project with ABI, Anheuser-Busch InBev, and they have thousands of SKUs. But if we're not doing really all that much different things. The models aren't all that different between the SKUs, but if they don't see, Molson Light sold in the beer store in Saskatchewan, then the model's bunk. It's not real to them. So to people like that, and for cases like this, typically, and obviously all of this is typical, as opposed to applies to every case, your model's got to be robust, highly tested, and way too complex in terms of details.
There's always that little detail that if you have students in class, they're not so concerned about the realism of the model itself and whether Molson is in Saskatchewan or whatever, but they're very interested in trying to break your system. That's why robustness is important.
Okay, so let's see here. I got 15 minutes, I think I can do it. Management flight simulators. Typical attributes. Again, this is purely based on experience. There's no study here. There's no citations. I've been doing this now for, 10 years? This is what I've seen in 10 years. This whole presentation is like that. So it's a bit soapboxy, so don't take it as fact, argue with me. Management flight simulators, typical attributes. You run step by step, and there's a whole bunch of different interesting ways to do that. You can do it on a timer. So, this model advances once a minute. This model advances once a day. So a really interesting multiplayer game. I think it was the University of Maryland has this giant multiplayer game where they all play different roles as ecological managers in the Chesapeake Bay water system. And the game ticks along once a day for a week. So you make decisions in real time. But that doesn't always have to be the case. So you can run step by step, and there's different ways of doing it. By timer, by user interaction. So in a multiplayer game, it could be we all agree that we're ready to go. But since we're talking about single player here, the user presses a button and says, go to next year. I'm done. These games are also played, hey, that should be a big bullet on its own. These games are played once or twice. Replayability is really, really low on these sims. Imagine playing that pricing game twice. The competitors don't change their behavior. They do what they do. You play it 100 times, you'll figure it out. Just by trial and error, which is a really big problem. So you learn in Erling's experimentation course, all about users who show great results through trial and error. So if you give people 10 tries, they'll get it, but they won't learn anything. Okay, these games are a heck of a lot more game-like. They're gamey games. Audiences are put in a role. It's very important that you set the context and you make a fake company or you borrow from a real company, and there's context setting, and there's a lot of work you need to do before the user gets into the simulation to put their mind in the right place. And in here, you get to be M. Night Shyamalan. You get to do your twist. You get to hide information. You get to make the game interesting by withholding things. So that pricing game is a heck of a lot less interesting if you tell them exactly what demand is going to be 6 months in the future. There's no game at that point. I need 7,000 cars in Tampa and 2,000 in Miami because next week I'm going to have 7,000 rentals in Miami and 2,000 in Tampa. So building games like this is all about what information you're showing people, what information you aren't showing people, and you decide that based on what it looks like in the real world, and what's the minimum amount of information you have to give them for them to learn the thing you want to teach them. So these simulations, you already know pretty much what you want to teach them. That pricing game is all about market segmentation. So you want to learn about that, so we need to set up a scenario where if you don't know that, you're going to fail. Also in these sims, users don't control everything, whereas in the scenario analysis tools, we give users a checkbox for everything. Here, users don't control assumptions. They don't control customer demand. User actions are constrained by real-world examples. When do you use a sim like this? To train people. One of the biggest uses for sims like this is in training. I think Foreo got its start actually doing lots and lots of training simulations, teaching people how to solve a problem. You do it when user engagement's important. So the scenario analysis tools are really hard to get a big audience excited about. It's pretty boring. You do it when users don't trust or understand system dynamics and you want to build confidence in the process. Because in cases like this, when you sell the project, it's not, hey, I'm going to build a system dynamics model that helps explain how to do market segmentation and pricing. They go, what the hell is system dynamics? I've never heard of it. Or if they have heard of it, they say that's really small and a weird field and it doesn't apply to me. So what you tell them is, I'm going to help you build a tool that helps you to make pricing decisions. And then you build a tool that helps them make pricing decisions. And guess what? It uses a system dynamics model. And when they get curious how you do it, you can teach them about system dynamics. But you're not walking in there and shoving system dynamics down their throat. You are walking in there and you're telling them that you have a solution for the problem they want to solve. Okay. You do it when your insights from your model can be revealed within the dynamics of a single run or 2 runs. If the only way you can learn about the insight of your model is through the gaps between 7 different runs, you're never going to be successful with a management flight simulator, because if people run it more than twice, they've spent a lot of time running a simulation. So if the only way you can teach people, how to run a business is to have them do it 7 times, you got to do a scenario analysis tool. You also do it when you want users to gain experience with a discipline or a task. These are also really great for competition, because typically you get a metric at the end that you can compare across everybody. And you use it as tests. So often, people will use tools like this to filter people out. Who really knows how to apply the thing I just taught in class? It's the best way to do that. So pros and cons. Better engagement, more real-world realistic. Typically people don't question the simulation logic. They take them a little bit less seriously. They're games. They're simpler, less robust models required because you're not going across the full state space. They're very constrained. They're constrained in their number of decisions. Oftentimes they're constrained in their range of decisions. You can't spend more money than you have. You don't cover the full state space of the model. So that's kind of, in my mind, a con. So pros on the left, cons on the right. Unless you do it right, they come off as hokey and corny. And even when you do it right, they come off as hokey and corny. There's typically way less systemic understanding developed intrinsically. In order to get that systemic understanding, you need to do it through a debrief. You need to do it through getting people to dig deeper. Because there's less questioning and explaining of the simulation logic, they just don't get there. You have to bring them there. And replayability is super low. And message leakage risk is really high. So let's say I have 3 sections of, introduction to marketing. My first section plays it at 9 in the morning, my last at 5 at night. The kids from 9 in the morning can talk to the kids 5 at night. And if your M. Night Shyamalan twist comes out, that's it, the game's blown. So there's risks. Alrighty, so I've been yapping at you for way too long about what interfaces are and why they're important. Hopefully now you believe that they're important. How do you make one? Well, you got to land the project. You have to scope and design the deliverable. And I only have like 3 more slides left, I think. And I'm trying to stop at 1:30. And we'll break, and then we'll actually build stuff. So with Foreo, I've used this process. And this is actually how we did consulting projects. Projects would range anywhere from $50,000 to $300,000 in terms of size, but we use this process on all of them. Projects are iterative, and their scope is based on a generalized concept of the deliverable and a number of iterations. So you'll never, ever, ever get a project in the real world where somebody says, I know I need super specific widget X with thingamabob Z. If you get a customer like that, you're the best. I've never once, though, ever found a customer who knows what they want. So the way that we deal with this process is narrowing down the list of unknown unknowns. The whole process is how do we take these unknown unknowns and turn them into known unknowns and then known knowns. So we'll have 2 phases, a design phase and a development phase. Both phases are iterative. So when I say iterative, that means we sign a contract that says, we're going to work on a tool that generally solves a problem. We're going to meet, 5 times and show you deliverables on each of these 5 meetings. We don't know what those deliverables are yet. So in terms of software methodology, if any of you are familiar with this, it's more agile versus waterfall. Waterfall is you write a giant spec document, 1,000 pages long, and everything is in the spec, and the developer goes and reads the spec and implements stuff. Versus agile, where we kind of accept that we have no clue what we're doing here, but we'll figure it out as we go, and we meet every week, and we make decisions about what we need to do now, what we can put off later. Anyway, in the design phase, you iterate. You show, wireframes, mock-ups, storyboards, until you get kind of the simulation on paper set up. That process kind of helps you determine your model boundaries. Because when you start a project like this, you don't even know what the model is yet. All you know is that you're going to develop a simulation that helps people understand the concept of batching. That's what, a customer will come to you and say, I need to teach people about batching. Okay, well, how do you want to do that? Alright, so the design phase, the goal is to develop a series of mock-ups and wireframes of the deliverable for the development phase. So in the design phase, we design the simulation. In the development phase, we build stuff. We set the scope here. The model concept is fully fleshed out. So in the case of Benihana, they come to us and they say, okay, we want to teach people about batching. All right. Well, what case studies do you have? Oh, we have got this really great Benihana case study. Alrighty, let's use that. Well, what do we want that simulation to look like? How do you want users to interact with it? What buttons are they going to press? What pages are there going to be? How are they going to learn this material? All user interaction in this case is really designed and lightly storyboarded. And I'll show you examples of this stuff. The process is essentially a funnel. You're taking what could be anything and you're narrowing it down into something. We did this typically iterations of a week, 5 of them. And then I describe everything in terms of roles, not people. So there's a couple of roles within these projects. You have designers, you have developers, you have project managers, you have modelers, and all of these different roles need to interact on these projects. So the designers need to be in, obviously, in the design phase. But you also need a liaison to the developers, because the developers might not necessarily know, might not necessarily be able to implement what the designers spit out. Oftentimes, so these are the same person. You could have the whole project be one person with 5 different hats on their head. But you have a designer, a developer, a project manager, and a modeler.
Oh, really? I'm sorry. The designer, is it a UI designer?
Yeah, so somebody who knows Photoshop and InDesign, somebody who's got knowledge of graphic design, typography, somebody who knows how to make something look good.
And who would be the developer liaison?
So typically that's a developer from the project or the project manager. Somebody who knows how to write the software that this tool is going to be made with. Because the designer may say, well, wouldn't it be really, really great if, we had, the Samsung VR goggles and, they walked through a room and they pressed buttons, and then the developer's going to say, yeah, but this project budget is $50,000 and that's a $50 million project. The developer liaison helps keep the designer on track so that when this actually does get to the person who's responsible for coding stuff, they can do it within the budget provided. Because in all of these cases, unfortunately, at least in my career, we've needed to make money doing this. We couldn't just do it because we enjoyed it. Well, that's a part of it, but we had to make money. If we weren't making money, then I wasn't getting paid. If I'm not getting paid, it gets hard to eat. Okay, so here's a wireframe. So this is what I mean when I say wireframe. I don't know if any of you have played with Stella Modeler for the iPad, but this was a wireframe that was made before we developed it by a friend of mine who actually used to work with me at Foria, who then went freelance and blah, blah, blah. But anyway, it's a black and white, simple, low fidelity, really easy and cheap to create picture of what the thing is going to look like. There's a whole bunch of tools out there for doing this. I think one of mockups.com, another that I used to use years ago was called Balsamic. They're tools where you drag and drop stuff out. None of this stuff works. You can't hit this button. We didn't actually end up going with something that looked like this, but this is really cheap to create. This takes a designer 30 minutes to make. If I had to code this out as a developer, this would take me 3 weeks to make. And if we find out we don't like it, which we didn't, it's way easier and cheaper to spend 30 minutes of a designer's time than 3 weeks of a developer's time. So we take these wireframes and we turn them into mock-ups. So once we get to mock-ups, we know with the wireframes how the interface is going to work. We have kind of a layout, a general idea. We know what they're going to learn. We know the case they're going to learn it in. We know the pages of the simulation. We know what graphs they're going to be. We know what buttons they're going to be. Now what we need to figure out is like the really designy stuff. And I'm bad at this. I'm not good at design. I'm not an artist. I can barely write my own name with my hand. But here we color things and we make them look like they will look so that we can take these, because oftentimes the way that these projects would work is we would get a client to agree to do the design phase. Because let's say the design phase was going to take 5 weeks, it would cost $15,000. Companies were willing to spend $15,000 to figure out if they wanted to spend the $150,000 to actually develop the project. So